Hello everyone. In this video I'm going to show you how to solve the HackerEarth problem minimum and XOR, which is a part of March Circuits 20. So it is live right now, but I'll be posting this when the contest ends. So basically in the question we're given an array A of n integers and we have to find the minimum value of the expression AI and AJ XOR AI or AJ, where I not equal to J. So before we get to solving it, I would like to show you something. So as you know, A XOR B, this is XOR. So A XOR B is simply A not A and B plus not B and A. So suppose I take A as AI and B as AJ. So suppose I take this and then I try to simplify it. So what we're given in the question, what we have to find out in the question is A or B and the XOR of that with A and B. So if you try to simplify it with the XOR formula, with this formula, then what will this become? This will become A plus B, the complement of that into AB, or A plus B and the complement of AB. Now if you simplify it further using De Morgan's law, the left term will become A complement, B complement into AB, this will stay as it is, plus A plus B, and the term on the right will become A complement plus B complement. The plus is OR, and so if you simplify it further, if you see on the left, the term is A naught into B naught and B naught and A and B. So this will become just 0. So, and the term on the right will be A plus B and A complement plus B complement. And 0 plus anything is that itself, and false or something is that itself. So this will essentially become this only. And if you simplify it further, this will become plus A B complement plus B A complement plus B B complement. And again, A into A complement, or A and not A becomes 0 and B and not B becomes 0. So this will essentially be plus B A bar. So if you simplify everything, it will turn back into A and not B, or B and not A. And if you look closely enough, this is simply A XOR B. So all of this is nothing but A XOR B. So in essentiality, what we have to do in the question is simply find out the minimum value of AI XOR AJ. So that is what we're going to do. We have to find two elements in the array such that their XOR is minimum. Now, one way of doing it is to look at every XOR. So one way of doing it is to compare every two element in the array, but for that you'll require two loops. And if you look at the time constraints, which that will give you TLE for many of the test cases. So what we're going to do is we're going to sort the array, and our answer will be in this variable min, which has this value initially, and I'll be showing this in the end, min. So if you sort the array and then if you look at every two continuous elements, then you'll find the two elements which will have the minimum XOR. So if you have any array, if you sort it, then the minimum value of XOR between two elements will be among two continuous elements. So I'll be checking for every two continuous elements, and minus 1 I plus plus. So I'm saying for every two elements, if AI XOR A of I plus 1 brackets, if it is less than min, then min is equal to that AI XOR A of I plus 1 simply. And in the end, cout min. So let's try to see if it works. Basically what I'm doing is I'm sorting the array and I'm finding out the XOR of every two continuous elements and then storing the minimum value. So as you can see, this passes all the test cases within the time limit because we did this in O of n log n time. So the time complexity of this will be O of n log n as we use sorting and then we did it in linear time.